നമസ്കാരം. എല്ലാ കുട്ടികൾക്കും ഈ ചാനലിലേക്ക് സ്വാഗതം. ഇന്ന് 9th ഫിസിക്സ് ഫസ്റ്റ് ചാപ്റ്ററിൻ്റെ സെക്കൻഡ് ക്ലാസ് ആണ്. ഇന്നിവിടെ ആർക്കിമിഡീസ് പ്രിൻസിപ്പിളും പ്രിൻസിപ്പിൾ ഓഫ് ഫ്ലോട്ടേഷനുമാണ് ഡിസ്കസ് ചെയ്യുന്നത്. സോ അവർ ടോപ്പിക് ഈസ് ആർക്കിമിഡീസ് പ്രിൻസിപ്പിൾ. ബിഫോർ ഗോയിങ് ടു ദ എക്സ്പെരിമെൻറ്റ്, let me tell you a story. The story of Archimedes. Archimedes was born in 287 BC at Syracuse, a port city in Italy. He lived during the rule of Hiero II. King Hiero commissioned a goldsmith to fabricate a crown. He commanded Archimedes to find out whether there was any impurity in the crown. Archimedes was perplexed. He was confused. He knew that the density of pure gold could be calculated by dividing the mass of the gold bar by its volume. We know that to find density, we can divide mass by volume. His confusion was how to calculate the volume without damaging the crown. Without damaging the crown, he do not know how to calculate the volume. When he stepped into his bath, he could see water overflowing. This made him realize that he could calculate the volume of an object by finding the volume of the water displaced by it. By finding the density and volume of the gold, he could prove that the crown contained impurities. By knowing the density and volume, he could find the mass. By finding the density and volume of the gold, he could prove that the crown contained impurities. He was stabbed to death by a Roman soldier in 2012 BC during the Second Punic War. This happened when he was engaged in the complicated mathematical activities related to circles. He was a mathematician too. This is the story of Archimedes. Now, the experimental setup is given in figure 1.6. This is the experimental arrangement. The procedure of this experiment is, first we have to find out the buoyancy on a stone and an iron block in water. Using an overflowing jar, find out the volume of water they have displaced. That means, first we have to dip a stone into this water and the water is taken in an overflowing jar. When the jar is overflowing, the overflown liquid is collected in another bottle or jar, and this has to be weighed. That is, we are collecting the liquid displaced from this trough or from this overflowing jar when the stone is immersed into this overflowing jar. Weight of the stone in air, and then we find the weight of the stone in water using this spring balance and finding the difference in their weights, that is finding the weight in air minus the weight in water, we get the buoyancy or weightlessness of or loss of weight of stone. This is equal to the buoyancy. Similarly, we have to calculate the buoyancy of an iron block. For this, we have to tie the iron block spring balance and first find the weight in air and then find the weight in water. Then we can calculate the buoyancy exerted on the iron block by the water. Now let us go through the video. Here the experiment is shown and let us watch this. Using a spring balance, weight of the plastic vessel is measured and it is 0.1 Newton. The weight of metallic block is then found. using the spring balance. It is 2.1 Newton in air. Now the metallic block is immersed in water and its weight is found. It is 1.4 Newton. Since its weight in air is 2.1 Newton, then the loss of weight or buoyancy is 2.1 minus 1.4, that is equal to 0.7 Newton. The weight of the overflowed water is then found out and it is 0.8 Newton. Also 0.1 Newton is the weight of the plastic vessel. So the weight of the overflowed water will be 0.8 Newton minus 0.1 Newton, that is 0.7 Newton. The buoyancy and weight of the overflowed water is both the same, that is both are 0.7 Newton. Tabulate the results in table 1.5. Now the results obtained are tabulated. From the table, by analyzing the table, we will reach the conclusion that the loss of weight, that is the buoyancy. Buoyancy is equal to the weight of water overflowed. That is, in each case, when we dip the stone into the water, we find the weight of water overflowed, and also when we dip the iron block into water, some water will be overflowed and we measure the weight of this overflowed liquid in each case, and we find if there is any interrelationship between the loss of weight or buoyancy and the weight of water overflowed. This is the experiment procedure. Before that, by analyzing table 1.5 and find answers to the following questions. First question is this: what is the loss of weight of stone in water? What is the loss of weight or buoyancy of the stone in water? That is, the loss of weight of stone is equal to weight of the object in air minus weight of the object in water. What is the relation between the buoyancy experienced by the stone and the weight of water displaced by it? What is the meaning of weight of water displaced by it? Displaced means when we put the stone into the beaker, into water, some water will move from that and the stone occupies the space of this removed water. This water, this overflown water is called the displaced water. Displaced water. That is, and we find the weight of the displaced water by collecting it into another jar, and we find that the weight of the water displaced is equal to the buoyancy. This is the principle discovered by Archimedes. What is the relation between the buoyancy experienced by the iron block and the weight of water displaced by it? Here we can see that the object, if the object is a stone or iron block, for both the object, for every objects, we can see that this relation is the same. That is, for every object, the buoyancy experienced by the object will be the same as the weight of liquid displaced by the object when we immerse the object into the liquid. What do you infer from this? We have learned that the buoyancy that a liquid exerts on an object is equal to the weight of the liquid displaced by it. This is called Archimedes Principle. This is called Archimedes Principle. Now, what is Archimedes Principle? That is the buoyancy that a liquid exerts. Buoyancy is the force exerted by the liquid. Therefore, the buoyancy will be equal to the weight of the liquid displaced by it. Buoyancy is equal to the weight. Weight of what? weight of the liquid displaced by it. This principle is called Archimedes Principle. Now let us define Archimedes Principle. When an object is immersed partially or completely in a fluid, the buoyancy experienced by will be equal to the weight of the fluid displaced by it. Here we study the force of fluids. Even though we have taken water as an example, this Archimedes principle holds good for fluids. We know that it is the general term we use for liquids and gases together. Thus, we can say that or state that the Archimedes principle as when an object is immersed means when it is dipped partially or completely, when either it can be immersed partially or it can be immersed completely, fully in a liquid, then the buoyancy experienced by it will be equal to the weight of the fluid displaced by it. Now, flotation is the next topic. Here, make a small vessel using an aluminium foil of length and breadth 10 cm each. Place this small vessel on the surface of water in a trough. Trough means a tumbler. Does it sink? Unfold the vessel of aluminium foil. Fold it many times till it becomes a small piece. Now put it on water and what do you observe? We can see that the aluminium foil, when it is made in the form of a vessel, it has greater volume and it can displace more liquid from water. And when we fold it in such a way that it becomes a small piece, then the mass does not change but its volume changes and the weight of the liquid displaced by it also changes. When the aluminium foil was in the form of a vessel and then folded into a small piece, was there any change in its mass or weight? We know that the mass doesn't change. When we change the shape of the aluminium foil, its mass does not change. Now, what about its volume? Will there be any change in its density then? Of course, the volume changes because volume is the space required to occupy. When we make the aluminium foil in the form of, or it is in the form of a vessel, then its volume is greater compared to when we make it in the form of a ball or small piece. Then its volume decreases. When the volume decreases, surely the density of the aluminium foil increases because density is equal to mass by volume. When the denominator decreases, then the value increases. Answer will be greater. Therefore, as volume is less for small aluminium piece, when the aluminium foil is converted to a small piece, then its density increases. Why does aluminium foil vessel float and the folded foil sink? Now we can easily answer this question. That is, why does aluminium foil vessel float? When we made the aluminium foil in the form of a vessel, it floats on water, and when the folded foil is put into water, it is seen to sink. The aluminium foil vessel floats because its density is less, and the folded foil sinks because its density is greater compared to water. Let us examine the reason for this by means of an experiment. Let us put a piece of stone, wood, rubber, cork, etc. one by one into the water. Which among them floats on water? Among these which are floating, surely the stone will sink, the wood will float, rubber will float, cork will float. Why do they float on water? Now we have to answer this question. Why certain objects are floating over water and some others are sinking on water? Find out the buoyancy and the weight of water displaced by each floating body and record them in table 1.6. The weight of the body, the buoyancy and the weight of the water displaced. We have to compare, we have to find, is there any interrelationship between weight of the body, the buoyancy and the weight of the water displaced by each object. We can see that the weight of the body is equal to the weight of the water displaced. Find out the interrelationship of the weight of the body, buoyancy and the weight of the water displaced. The weight of the body is equal to the weight of the water displaced. We can see that the weight of the body is equal to the weight of the water displaced. Write down the situation when a body will float on a liquid. The situation when a body will float on a liquid is that if it can displace an amount of liquid greater than or equal to the weight of the object, then it can, or object or body, it can float on liquid. This is called the principle of flotation. What is the principle of flotation? Weight of a floating body is equal to the weight of the fluid displaced by it. That is, the weight of the floating body is equal to the weight of the fluid displaced by it. If a body can displace an amount of liquid or fluid equal to the weight of the body. If a ship has weight 100 Newton and if it can displace a liquid or water of weight 100 Newton, then surely it can float on water. If it can displace only 80 Newtons, then it will sink. Water equal to 150 Newtons, then also it can float on water. This is the principle of flotation. What is the principle of flotation? Weight of a floating body. When a body floats, it is called a floating body and then its weight is equal to the weight of the fluid displaced by it. When the body is put in liquid, then it displaces some amount of water. And if we find the weight of the displaced water, then the weight of the body also will be equal to this weight of the displaced liquid. That is, the weight of the liquid displaced is equal to the weight of the body itself. Then only the body can float. When a body is fully immersed in a fluid, the volume of the displaced fluid will be equal to the volume of the body. And we can say it, the principle of flotation can be stated in two ways. Either you can state this one, that is, weight of the floating body is equal to the weight of the fluid displaced by it. It is similar statement is that when a body is fully immersed in a fluid, the volume of the displaced fluid will be equal to the volume of the body. When a body is fully immersed in a fluid, if a body is fully immersed in a fluid, the volume of the displaced fluid will be equal to the volume of the body. Identify the reasons for the following based on what you have learned. A piece of stone experiences a loss of weight while inside water. What is the reason? Because the stone experiences buoyancy, or the water acts a force on the stone, which is called buoyancy. Though an egg sinks in pure water, it will float on salt water. What is the reason? That is, the egg sinks in pure water because pure water has less density compared to salt water. So, the egg sinks in pure water where the density of egg is greater than that of water, and it will float on salt water because the egg's density is less compared to that of salt water. Kerosene floats on water because kerosene has less density compared to water. A ship floats on water because a ship can displace an amount of water equal to its weight. When a body was placed in a liquid, it remained in the same position. This occurs when the weight of the body is equal to the weight buoyancy experiencing buoyant force acting on it.